Jack Kilby created the first integrated circuit prototype in 1958, and only 6 months later, John Awareney added a silicon wafer base to create a more reliable circuit. Finally, Robert Noyce invented a way to have the connections run horizontally across the surface of the wafer instead of through wires coming up from the surface. The integrated circuits in all of our devices today are similar to the ones Noyce worked on, just more precise and complex. In this image, you can see the complex pattern of connections formed by layers of metals and semiconductors, including silicon. Although various circuits may include different semiconductors, the silicon substrate is consistent with most integrated circuits. Other common components include niobium, aluminum, and molybdenum. On the left is the first integrated circuit. The base material was germanium, the metal was aluminum, and the wires were gold. The whole thing was held together by wax. This first integrated circuit was very flimsy. Soon after this first invention, the germanium was replaced by silicon, and the integrated circuit was made planar, which is consistent with integrated circuits today. In the near future, graphene will replace silicon. The 6-member carbon ring with 3 double bonds is expensive to produce, but when research yields lower costs, its qualities will attract many electronics manufacturers. Graphene-based circuits would allow for electronics to be fast, flexible, strong, and even possibly transparent. Silicon and silicon alloys are used in almost every microchip in almost every electronic device today. Silicon is the primary component of glass, ceramic, semiconductors, and silicones. It is also used in resins and oils, as well as photovoltaic cells. In 1824, Berzelius isolated silicon by heating potassium and removing byproducts. Today, silicon is made by heating carbon and silicon dioxide or sand to very high temperatures. Silicon is the main component of sand, quartz, flint, and opal. To make an integrated circuit, conducting components are inserted into grooves in a single semiconducting silicon chip. Hundreds of integrated circuits are made simultaneously on a single wafer, then divided into individual chips. Manufacturing takes place in a clean room with equipment operators wearing lint-free masks, gloves, and garments. Integrated circuits are essential to almost all electronic devices used today. Their wide use is due to their very inexpensive cost, high versatility, and low power requirements. Additionally, their small size and high processing speeds allow the equipment they are part of to conduct a wide range of information. Another beneficial characteristic is that the integrated circuit can be reprogrammed without having to redesign the circuitry. As mentioned previously, integrated circuits are very cheap to produce. Manufacturers of integrated circuits sell them to companies that incorporate them into electronic devices. Companies such as Apple, Sony, and Samsung depend on these integrated circuits and are worth many billions of dollars with as many jobs produced by each. Silicon-based electronics have an extremely important role in the medical technology industry as well. Silicon is a metalloid element, meaning it has characteristics of metals and nonmetals. It is also a semiconductor. This means it conducts electricity better than insulators, but not as well as conductors. Silicon is the second most abundant element found in Earth's crust at 27.6%. Pure silicon is silvery and shiny, and though it is hard, it is very brittle. Another unusual property of silicon is that it expands as it freezes. Thank you for watching.